So, this lecture is on regression, which is an important concept in machine learning. Regression is a type of supervised learning where the goal is to predict continuous outcomes to based on input features. So, it's a kind of supervised learning. Now, some of the general concepts are regression are that it's firstly regression is type of predictive modeling technique that estimates the relationships among variables. Now, what is the dependent variable? It's the target or response variable, the variable that aim to predict. Now, independent variables, they are the predictors or features. So, the dependent variable is target or response, and the independent variables are predictors or features. The input variables, these are the input variables which are used to make the predictions. Now, linear regression. Linear regression, it is a regression model where the relationship between the dependent and independent variables is assumed to be linear. Now, in multiple linear regression, it is a linear regression where regression model involving more than one independent variable. In polynomial regression, it's a regression model where the relationship between the dependent and independent variables is modeled as an nth degree polynomial. Relationship between the dependent and independent variables is modeled as an nth degree polynomial. Now, what is logistic regression? Logistic regression, a regression model used for, again, this is a regression model, it is used for binary classification, where the output is categorical. Something like 1 or 0. Or true or false. Something like that. Then ridge regression. Ridge regression, it is a type of linear regression that includes a regularization term to prevent overfitting. In lasso regression, it's a model that uses L regulation to shrink some coefficients to 0, effectively performing feature selection. In elastic net, it's a regularized regression method. It's a regularized regression method that combines lasso and ridge penalties. Support vector regression. It's a regression technique based on support vector machines used for predicting continuous outcomes. So it is support vector regression. Decision tree regression. It's a non-parametric model. It's a non-parametric that splits the data into branches to make predictions based on features. Now, in random forest regression, an ensemble learning method that combines multiple decision trees to improve the accuracy of regression prediction. Gradient boosting regression, a boosting algorithm that builds multiple regression trees sequentially to minimize prediction errors. A boosting algorithm that builds multiple regression trees sequentially to minimize prediction errors. A regression technique that incorporates prior distributions. A regression technique that incorporates prior distributions over model parameters and updates them with observed data. A regression technique that incorporates prior distributions over model parameters and updates them with observed data. So, Bayesian regression technique that incorporates prior distribution over the model parameters and updates them with observed data. Now we get into some more deeper concepts. Loss function is a function that measures the difference between the predicted and the actual values, like mean square error, mean absolute error, something like that. Then the cost function. Cost function is a function that calculates the optimization objective, often minimized during training. It is typically the sum of the loss function over all training samples. Ordinary least squares, a method for estimating the parameters in a linear regression model. Estimating the parameters in a linear regression model by minimizing the sum of squared residuals, sum of squared errors. So it is a method for estimating the parameters, method for estimating the parameters in a linear regression model by minimizing the sum of the squared errors. The residuals, these are the difference between the actual and predicted values. Now, coefficient of determination. Coefficient of determination is a statistical measure that represents the proportion of variance in the dependent variable that is predictable from the independent variables. Very interesting concept. Adjusted R square is a modified version of R square, which is the coefficient of determination that adjusts for the number of predictors in the model. Then comes multicollinearity. Multicollinearity is a condition where independent variables are highly correlated with each other, which can affect the stability of regression coefficients. A condition where independent variables are highly correlated with each other, which can affect the stability of regression coefficients. Now, heteroscedasticity is a condition where the variance of the residuals is not constant across all levels of the independent variables. Homoscedasticity is a situation where residuals have constant variance across all levels of the independent variables. Now, autocorrelation is when residuals are correlated with each other. Residuals are correlated with each other, which can violate the assumptions of the regression model. Gradient descent, it is an optimization algorithm used to minimize the cost function by iteratively adjusting model parameters. Now, stochastic gradient descent is a variant of gradient descent where the model parameters are updated for each training sample rather than the each data set. Regularization, a technique used to prevent overfitting by adding penalty term to the loss function. Now, overfitting is when a model is too complex and captures noise in the training data, leading to poor generalization on new data. Model is very complex, it captures noise. Underfitting is when a model is too simple and cannot capture the underlying pattern in the data. Bias, the error due to overly simplistic assumptions in the learning algorithm, which can cause underfitting, and variance, the error due to models' sensitivity to small fluctuations in the training data, leading to overfitting.